So, I graded a bunch of the second part, or the first part, whatever, the other piece of the test. Mostly those that signed up to do a retake for you to see if it makes a difference or not. If it no longer makes a difference and you don't want to take it, don't come in. And those of you that are comfortably on the correct side of that 0, if you have an 81, don't come in to take a retake. Like, that's not gonna do anything. If you have an 89.1, okay, that's irritating, yeah, I'll see you at lunch. But change your mind and you don't wanna do the retake, don't come in. The only things left to go into the grade book possibly would be homeworks, and the majority you have done all of the homework, so the only thing that would do is actually hurt your grade if you didn't do the last one, and I'd put that in, and that would take your 100% in that 10% grade area and bring it down some. So I would say grades are probably done. The only thing that's going to affect anything is the retakes that are today at lunch. Today I wanted to go over any questions from day 28 homework, which was on mean value theorem, right? No, that were on extreme values. Were there any questions on those? Yes?
37.
Which I don't have written here, but 37.
I can read it? Yeah. I can read it too.
So the question said, identify any critical points and find the local extremes. Is that right?
Yeah.
Okay, so how do we find critical points, Cleo? Solve for x here. Okay, power rule. Actually, can I do that first? Can I multiply it out? Did I do the exponents right? Okay, so multiply by the power, lower the power. Multiply by the power, lower the power. Did I do it right? No, it's kind of a bad day. Okay, so Nick, where is this derivative undefined?
When the x is 0.
Okay, so that's one critical point. And where does the whole thing equal 0? Subtract one of them to the other side. Multiplying by that 1/3. I get x equals -4/5. Multiply by 3, the 3 is reduced. Divide by 5. Multiply by the x to the 1/3. F prime is 0 here. Undefined here. So those are my critical points. So Roman, did it just say find critical points, or did it say find the extremes?
I think it said extremes.
Okay, so then we need to identify the endpoints. Was I given any endpoints in 27? I think it just gave me the whole equation. So that is, what is the domain of this? Are there any natural restrictions? Do I have any like square roots or divide by zeros or things that I need to cut out so that Chris is shaking his head? Not the derivative, but the function. So the function is the function just a polynomial? Is it all reals? Okay. So then I don't have any endpoints to put on here. I am going to put on my 2 critical points. type it in on the calculator, get some answers, and well, at 0, it's 0, and at -4/5, I don't know. So you exercise for the reader, type it in. But I believe this is a maximum, this is a minimum, they're both local because the arrows go on forever.
Couldn't you also do the number line thing and get the positive?
We could do the number line and check the first derivative. But that's, I don't have the question printed, so is it asking for the exact value of the max and the min? If it did, I would type that in. Ivy?
About the same thing, but it's like a product rule.
Yeah, that's fine.
Is that okay?
I was wanting to be lazier than our rules, and it's easier for me right now. I couldn't add in the first period, so that's why I had to have to record this period. It's kind of trouble.
Would you be able to show how you got the slower from -4/3 x to the 1?
Okay, so are you okay with the part that I just subtracted the other side? Okay, so I'm gonna cross multiply. -12 equals 15 x to the 1/3 times x to the 2/3. I add the exponents and I get x. -12 over 15 reduced, take a 3 out of the top and bottom, I get -4/5.
Sorry, I got lost with the x to the 1/3 there.
Okay. X to the 1/3 times x to the 2/3.
Oh, okay, okay.
We add the exponents and we get x to the 1. Anything else on these things? Was 27 assigned or not? That was the rabbit hole.
Yes.
Yeah.
It was. Oof. You guys okay with that one, or do we need to do it? Owen? Yeah, we should do that? So it says find the extreme values. First thing, what's the domain? Renee, how do I find the domain of this function?
You set stuff inside and square and
Okay, so we need to find where the stuff on side is 0 or negative. So, all right. I need to find where 3 plus 2x minus x squared, which way do I want to do it? Do I want to find the things that I want to kick out or the ones that I want to keep? Kick out, so where is this less than 0, less than or equal to, or just less than? Just less than. Okay, I am not good at factoring with the lead coefficient being negative. So I'm gonna just factor out a -1. I don't want to multiply by -1. That caused a lot of trouble in first period and made us do concept dyslexia. All right, so my critical points, well, this is just the function. Putting in 0, I get negative times positive, but there's a negative on the outside as well. Putting in -8 million, that's a negative times a negative times a negative. Putting in +8 million, I get a positive times a positive times a negative. The stuff that works is -1 to 3. So that's the domain. So Roman, that's why I was asking about on 27. Was there any natural restrictions that came out of the problem? That one, no. But this one, the domain in the first place, is -1 to 3. If I found a critical point that was like 5, I would throw it out because it's not part of the function. Okay, so now I've got my things to test. put in my endpoints, and now let's find critical points. What's the derivative? Multiply by the power, lower the power, and multiply by the derivative of the stuff inside, which is 2 minus 2x. Reducing the two, okay, so where is it undefined? It's still undefined everywhere that this was undefined. And now also the endpoints, because I can't do the divide by 0. And one new place. Yeah.
For the taking the derivative of it, like initially, wouldn't it be 1/2 times the square root of 3 plus 2x, x squared to the negative 1/2? So isn't
Right,
that square?
Okay, no. So this to the negative 1/2 is that square root downstairs. This is to the square root here. Is to the 1/2. Is it in the top of the denominator, or sorry, the top of the fraction or the bottom? Bottom. So the exponent is already negative 1/2. Yeah. Okay. So again, this one is undefined at the edges of my domain. And where is it 0? Where's
X equals 1.
where the numerator is 0, which is x equals 1. So, all right, plugging things in to the original function, 3 minus 2 minus 1 is 0. Into the original function, 3 plus 2 minus 1, that's 4. Square root of 4 is 2. Plugging in 3 plus 6 minus 9 under the square root. So absolute maximum is 2, absolute minimum is 0. Where did they happen? The absolute minimums happened at the endpoints of negative 1 and 3. The absolute maximum happened at x equals 1. Yeah.
Alright.
Yeah. Okay. What else? So the extremes, like the important thing is, like, sometimes it takes a lot of work to figure out what are the endpoints, what's the domain. There were some restrictions that happened with the function or not. But when you find those, make your chart, make your t-table, go back to the original function, plug in your endpoints and all your critical points in between, get those y values and do the Sesame Street game of which one's taller, which one's smallest. Yep.
So you didn't include any points outside of the domain of the denominator because you set that as the domain at the beginning?
Yeah, because the original function didn't have numbers like negative 10 weren't allowed to be in there because you would have gotten the square root of negative 17 or something. So if the function didn't have it, no need to look in your derivative.
For 41, it's like a straight line. Does that mean that there's like no maximum?
Okay, couple ways to do 41. It's two straight lines coming together. Is it continuous? That's my first question looking at this. So as we approach 1 from the left, I get 2, which is also the function of 1. And as I approach 1 from the right, it's 2. Okay, so from the left and the right and at the function, it's equal to 2, so it's continuous. Then, really I would do this graphically. This side is what? 4 minus 2x. This side is x plus 1. The absolute minimum is 2. There is no maximum because it goes on forever. We could do the long way and do the derivative. It's negative 2 here, and the derivative over there is positive 1. The slope went from negative to positive, so have a minimum? Kind of, sort of, yes, no?
What are the local extreme
I mean, there is no local, it is just the absolute. And, you know, if you're Katie Ledecky and you're the fastest, with the shortest, lowest time here, you're also the one with the shortest, lowest time in the world. You're locally the best, both nationally and globally. So the only local extreme is it's also absolute.
For this graph, if we're asked to find like the minimums and maximums, but in an interval, so like, if like 0 to 2, would there be an absolute max?
So if we change this and said, I'm only interested in 0 to 2, yes, there would be an absolute max. You would plug in the endpoints that you chose and our critical point, which was where it broke, plugging in the 0 and plugging in absolute max would be 4, absolute min would be 2, and a local max would be 3. Okay. Any other issues with extremes? If the function's continuous and differentiable over a closed interval, continuous and differentiable, you're guaranteed to have an all-time maximum and an all-time minimum. Have to. Everyone in the room must partake in the race. Someone will be fastest, someone will be slowest. And I will trip one of you to make sure I don't lose. This is an interesting exercise in understanding the data. Adam, what do you think? We want to find one of the graphs down here. At A, the slope is 0, at B, the slope is 0, and C, the slope is 5. Can you tell us which one it is or which one it isn't?
I think it's graph C.
Graph C, you think this one because why?
Because, yeah, it has a 0 at A.
Horizontal axis, or
Horizontal tangent is 0.
that word,
and
horizontal tangent.
at B, and then it could be 5.
Okay, it could be 5, yep. Anyone can match a different one? Roman?
46 is B.
46 is B because,
Well, really, the other two. Should I talk about the other two? I feel like I'm kind of jumping up.
well, okay. We'll do it the opposite of what you were, I know what you're gonna, the slopes are 0, they exist at A and B, and this has a negative. So you were gonna say, well, the other ones doesn't exist at the crinkles,
Yeah.
and there's only one crinkle with that one.
Yeah.
Okay, so at the corners, cusps. Okay. Okay, today's homework is mean value theorem. There's a whole bunch of them, and the directions, I changed the directions that are, and they're on this sheet. So. So for those guys, only find the increasing and decreasing. Don't actually go through the trouble to find the local extremes. for those guys, only find the absolute extremes, and for those guys, only find the critical points. And I don't have all of them up here. But there's some on the next page. Should I turn the page so that you can see them and do your little paparazzi thing?
Oh, here it says.
Says what?
49 instead of 49.
49 instead of 41?
It was 35, 39.
That could be pretty relevant. Okay, 49, not 41. Okay, so try a few of those, and if there's questions, we'll go over them. All right, well, let's look at the first one. First of all, I hate it, but I know Algebra 2, right? It's gonna be something like that. It looks like x equals negative 5/2 is where it's gonna.
Isn't it just?
So, okay, let's check. We made so many mistakes today, it's just not even funny. So we need to find where it's increasing and decreasing.
The derivative is zero.
So do the derivative.
So it's like never zero, but it doesn't.
Um, 5 minus 2x, where is
it's
it
never
0?
But you can't divide by zero. So
Where x is
that's like a
2 halves. And I asked only for the increasing, decreasing. You know the picture, but we're going to test the number line anyway. When x is 0, checking the derivative at 0, it's positive, so the slope is going to be positive, increasing from okay, the function is increasing here because the derivative is positive. And then checking like 8. 5, okay, that's going to be negative. Decreasing over
It's just decreasing.
5 halves to infinity. Why? Because f prime of x is less than 0. It's all the proof that you need to state. Okay? Are there any other ones that we should go over, like that there's some wrinkle that,
Just do the second number.
number 3? Okay. And maybe that's less algebra 2, more pre-cal, but I know it's gonna look like this. So looking at the function in the first place, 0 is not in the domain. Doing the derivative, multiply by the power, lower the power. Please don't do quotient rule. It's not wrong to do quotient rule, but it takes you longer. Critical point at x equals 0, but is it actually a critical point? No, because it's not in the original function. So how do we test to see if the function is increasing or decreasing? Well, I'm going to put my one place that things break. The derivative, negative over something squared, is decreasing over the whole domain, and the domain is this. Everything but 0. Any other funny wrinkles that we should talk about or leave you? Yeah. Which one?
13.
13? Which, way down here. Well, I'm kind of thinking we need a calculator for this one. And the directions said on 13, we're just finding increasing and decreasing. Owen, are there any things in the domain that I need to throw out, or do all reals work for 13? All reals, there's no divide by zeros. And there's no square roots of negatives. Okay, so the derivative, multiply by the power, lower the power. And again, I would need a calculator to find where this is 0. And yeah, I don't know. So (3x squared) minus 2 plus 2 sine x.
Hold on. Is this like -1?
Does anybody remember how to find zeros on a calculator? Like what I push? Arabella, do you remember what to do?
Yeah, second count, and then 0. Oh. Oh,
Yeah.
and then you like put on either side of the x intercept.
So I'm to the left of one of them and going to the right.
And then press enter, and then you press enter again.
Bye.
That's one of them.
Okay, so hold on, second quit. I'm going to store that x value in A. 0.559.
How do you store it that quickly?
So Lexi, like when we were on the graph, did she show you? I typed in the letter X because that's the X value, the value I wanted to keep. And this button, STO, is stored. And then hit the alpha key and then pick whatever green letter you like. I picked A. And so Arabella is going to tell me I got to do it again because there were 2 coordinates. So I'm going to go back to the graph. Second, calculate, pick the 0. And it takes so long for this to move. I'm going to type in -2. I'm to the left side. And now I'm going to type in 0. I'm to the right side. I'm going to hit enter. And I get the other 0. So Lexi, right here, if you watch, if I type in X right now, it gives me that number. And I'm going to hit stow. And I'm going to pick B. -1.126. And this, like, real shortcut thing, I wasn't given a graph, so you can't say, well, looking at the graph, I saw this. But if you draw a number line, label it with the derivative, this is a quadratic, it's a positive quadratic. I saw on the graph that it did this. So I know that these critical points, positive, negative, positive. I saw it on the graph. You can't say I saw it on the graph, but you can put this information on a number line and then interpret. We're asking just where it's increasing. It's increasing from -infinity to -1.126. How many decimals? 3. Since when? Forever. 0.559 infinity. Why is it increasing there? Because f prime is positive. Where is it decreasing? It's decreasing from -1.126 to 0.559. Why? Because the derivative is negative. I good, LA?
Yes,
Oops, undid it. Can I turn the page to bring the other problems back, or are people still on this page? I accidentally deleted the others. I will get them back.
No, we
It's 4 minus the second 4 minus 1 squared. Or 4 minus square root of 2. The second one should be done.
Oh, it's Pascal.
Yep.
Have you finished reading the?
Nope.
Okay.
I have them done.